I wanted to talk about explainable AI and how the interpretability techniques that you learn in the book paves the way for building an explainable AI system. But first, it's important to distinguish between what interpretability is and what explainability is. Interpretability is all about answering the how question, like how did the model come up with a prediction? How did the model use different feature values or how did the different feature values influence the outcome for the model, and so on. Whereas explainability is more about answering the why question or the why not question. Why did the model make this prediction and why not another prediction? And that is a totally different problem to solve, and I'll go into a bit more detail here. So let's look at another example here. The idea is to predict the income of an adult given certain input features. In this case, we're looking at the education level, occupation, age, gender, and race. And you want to predict what the income is. And in this case, we're just looking at whether the income is more than 50K or it's less than 50K. So it's essentially a binary classification problem. But suppose that a user challenges this model, or this model is being used to determine, say, the credit score of a user. The user may want to challenge the system to understand exactly why they were given a low score or a low income that may have influenced the score. In order to come up with a good explanation, we've sort of incorporated this explanation agent here that interfaces with the user, and where the user could question or ask questions to the agent, and the agent would provide an answer that would explain why the model made that prediction. There could be a bunch of questions that the user could ask here, and it is on the explanation agent to understand what it is. So that's a different problem of language understanding. But more importantly, it's about coming up with the right explanation for the user that actually answers the user's question, which is a different problem from actually determining what features may have influenced the outcome. There's a whole field dedicated to this problem, and it's called explainable AI, or XAI for short. And XAI is not just about artificial intelligence, it's actually at the intersection of three different fields: AI, human-computer interaction, which is all about dealing with human-centric technologies, or how humans interact with computers, and also the social sciences, which is essentially focused on how we receive explanations and what sort of explanations are satisfactory. There was an important paper published by Tim Miller that essentially said that explanations have to be contrastive. That is, rather than just answer the why question, it also has to answer the why not question. Why didn't the model predict another outcome as opposed to the outcome that it actually predicted? Now, to answer that question, you need to come up with counterfactual examples. You need to come up with examples that may have pushed the prediction to the outcome that the user actually cares about. So let's look at a contrived example here, where you have the education level that goes from, say, high school all the way up to doctorate, and the age here of the user. And say this is what the model actually predicted for that user, that the income was less than 50K. But the user actually cares about this outcome. Why didn't the model predict this outcome for that user? And in this case, the idea is to come up with counterfactual examples that would actually influence the prediction of the model. So in this case, the counterfactual example would say that the model would have predicted this outcome if that user had a degree that was higher than a high school degree, that is either a master's, bachelor's, or a doctorate. And that's essentially what the whole problem of coming up with counterfactual examples or counterfactual explanations is about. Now, there's an entire there are a host of different techniques that you could use to come up with counterfactual explanations or examples, but the whole process can be distilled down into this. The idea is to feed the explainer with the model, what the original input was, what the desired outcome is, and how many counterfactual examples it should generate. So going back to the example that we saw before, the original input was that the age was 30 and the education was high school, and the user cared about an income that's actually greater than 50K. Now, the idea for the explainer is to essentially come up with examples that would or changes to this input that would actually cause this outcome, or would change the outcome from what was actually predicted to the desired outcome for that user. And the optimization problem is essentially coming up with examples such that the distance between the model output to the desired output is minimized. That is, you essentially achieve the desired outcome. And the distance between the original input and the counterfactual example is also minimized. So the changes to the input has to be small enough so that you come up with a decent enough explanation for why the model predicted one outcome as opposed to another. There's a library or a technique that you could apply here, which is diverse counterfactual explanation. And there's a library that implements this technique called DICE. And this is the code that you could use to essentially come up with these counterfactual examples. The idea here is once you've loaded the dataset and you've initialized the DICE ML library with the data, and you need to essentially feed the model to the library as well. So this is the model that was trained on that data set. And then you could come up with examples for a given input and a given desired class or outcome here. And you could visualize this as a table or a data frame. And for the data set that I just spoke about, this is essentially a visualization of the data frame output that was generated by the DICE library, where say we were dealing with this input here of an adult who had a high school education and with all of these other attributes, and the outcome that the model predicted for this adult was income less than or equal to 50K. The DICE explainer essentially comes up with 3 examples here that show that if the education was either doctorate, master's, or professional school, or if the age was higher, this is something that doesn't have any bearing here. But I guess like what the model or what the explainer is saying, that an adult with more experience could earn higher. But in this case, what is actually relevant is that if the education level was higher, then there's a much higher chance that the model would predict the desired outcome for that adult. So this brings us to the end of the talk today. All of the source code that's used here, as well as in the book, can be found in this GitHub repo, which is github.com/thumpyman/interpretable AI book. Thanks a lot for tuning in, and I hope you enjoy this book.